Hi, my name is Giacomo Sala, and I'm currently Ambizione Fellow in the Department of Quantum Matter Physics at University of Geneva. I studied physics in Italy, in Milan. Then I moved to Switzerland, to ETH Zurich, for a PhD in magnetism. And in 2023, I came to Geneva because I want to work as a postdoc in the department. But since January 2025, I'm leading my independent Ambizione project thanks to the financial support of the Swiss National Science Foundation. So my project is about spinning and orbiting electrons. So imagine that this is an electron. And imagine we take a piece of a metal and we look at how the electron moves within this metal. So what we do is we apply an electric voltage. The electron will start moving, so it will produce what we call an electric current. And during this motion, the electron actually starts spinning around its own axis. We call this spinning motion the spin of the electron. This is a rather fundamental phenomenon that, for example, is used in magnetic memories to store information. But actually, it turns out that electrons don't just spin, but at the same time can also orbit while they are moving. So this is something that we know since a long time, but for also a long time, it was thought that this orbital motion is not really possible. So while the electron is moving, it should just spin, but it should not orbit. This orbital motion is in a sense similar to how our planet, the Earth, is orbiting around the sun. But what we have understood in the last couple of years is that, in fact, this orbital motion not only is possible, but it's actually, in many cases, more fundamental than the spinning motion of the electron. And this is what fascinates me, because this orbital degree of freedom adds an entirely forgotten piece to the overall puzzle of how electrons move in solids. So my research is about understanding how this orbital motion combines with the electric currents in materials at the atomic scale. And to perform such investigation, what we do is we take rather special materials that, when taken alone, are insulating, so we cannot have neither charge currents nor this orbital motion. But when we grow one on top of the others, we produce an entirely new state where electrons can flow and at the same time can orbit, can move. And once we have prepared these materials, which we normally do with such a machine, we can bring them to rather extreme conditions. So we cool them down to minus 272, 73 degrees, which is well below room temperature. And at the same time, we apply very strong magnetic fields. So magnetic fields that are a million times stronger than the magnetic field produced by our planet. And we need such strong conditions because this is the only way we can access the physical laws that determine the peculiarities of this orbital motion. So my Ambizione project started in January 2025, will run for the next 4 years, and will be hosted in the Department of Quantum Matter Physics, and in particular in the Designer Quantum Materials group led by Professor Caviglia. It will also include, beside my activity, the scientific research of a postdoctoral assistant who joined me recently. And together we'll be preparing these materials and studying them to really pinpoint the physical laws that determine this orbital motion. And eventually, if we understand them, we will be able to design new electronic functionalities and new electronic devices.